to Online Lecture 7 on suffixes. Here are the topics that we're going to be covering in today's lecture. So last lecture we went over 3 functional groups. Going from lowest to highest priority, there were amines, alcohols, and ketones. So we're going to go over 5 more groups today that are going to be higher priority than that. So above ketones, we have nitriles and amides. Amides and nitriles are both nitrogen groups. Above that, we have acid chlorides, esters, and carboxylic acids, all involving the C double bond O group. So let's start off with carboxylic acids. So carboxylic acid has a suffix of oic acid, and that is always going to be the highest priority group in any molecule that you have. And because there is a carbon in the carboxylic acid group, the numbering is always going to start with number 1 in the carbonyl carbon, unless the group is attached to a ring, in which case the suffix will be carboxylic acid and the numbering will start at the attachment point. So let's take a look at a couple of examples and maybe that'll make it clear. So in the first example, we have 2 carboxylic acids and the numbering is going to start within the group, like so. And so to name it, it's just going to be pentane, dioic acid. I don't have to add numbers because carboxylic acid always has to be on the end of a chain. And so its location is always going to be known. And in a dioic acid, it always has to be on both ends. So now for the second example, when it's attached to a ring, we start the numbering at the attachment point like this. And then we're going to name it based on the root, which is cyclo, pent-2-ene. Now the suffix is carboxylic acid, like so. Now finally, let's not forget that because that's drawn as a wedge, we have to take into account the stereochemistry of that chiral center. And so by priority, this carbon is number 1 because it has 2 oxygens attached. This carbon is number 2 because there's a double bond. This carbon is number 3 because it doesn't have anything else attached. And the hydrogen is number 4. And so that will happen so that the hydrogen is facing away. So my thumb is facing away from me. My fingers are sweeping counterclockwise. That happens on my left hand. So this will be S. Cyclopent-2-ene carboxylic acid, like so. So now let's talk about acid chlorides, which are the same thing as carboxylic acids, but instead of an OH, it's a chlorine. And we call that an oil chloride. Or as a prefix, it is a chlorocarbonyl. And so in these 2 cases, in the first case, again, we start the numbering in the group, and we don't need to specify the location because it always has to be at the end of the chain, and so it'll just be butane oil chloride, like so. And notice now we're introducing one exception where there are spaces in the IUPAC names, and that's only if the special name of the functional group requires that there's a space. So carboxylic acids and acid chlorides do have a space here. So now for the second one, it's a 3-carbon chain, 1, 2, 3. And because there are 2 acid chloride groups, we will just call that propane dioil chloride. And we don't have to specify 1 and 3 because they has to be at the end of the chain. Okay, next we're going to go over esters. Esters are a little different because they always have two groups attached. So the group on the carbonyl part is going to be part of the root with the suffix O8. We'll see this in an example in a second. The other group is going to be attached to the other oxygen, and that will be an alkyl substituent. So let me make this clear. So in this first example, there's a group attached with the carbonyl, 1, 2, 3, that is the root. The other methyl attached to the other oxygen is a substituent. And in this case, we would write methyl as the substituent. And this is another special case where there is a space, and we call it methyl propanoate, like that. And so in the same case here, this is going to be the root, this will be the substituent, and the ethyl is a separate word from the root, which is hexanoate, like so. And that's it. So let's keep going. An acid anhydride is a special type of molecule. It comes from the combination of two carboxylic acids by removing a water, as you can see in this reaction here. And so in the case where the two carboxylic acids are the same and they're combined, you actually just need to use their name once when you're naming the anhydride molecule. But if you're combining two different carboxylic acids, then the names just come from both of the original carboxylic acids, and you just name them in alphabetical order in the name. And then finally, the suffix that we use is oic from the carboxylic acid anhydride. So let's look at a couple of examples. So for the first one, if we had to think about what the original acid looked like, because it's two of the same one, it looked like this. And that would have been ethanoic acid, because it has a 2-carbon chain. Now, in this case, when you combine it, it will be ethanoic anhydride. Just taking the original name and changing acid to anhydride. And because it's both the same, you don't have to say ethanoic. It's just assumed if it's just one, that's two of the same acid. Now in this case, the common name of that acid that we started with is acetic acid, so you could also call this acetic anhydride, but the IUPAC name systematically will be ethanoic anhydride. So now for the second example, remember when we have the carboxylic acid attached to a ring, the suffix is going to be carboxylic acid, and so the ring with the carboxylic acid will be benzene carboxylic acid. And so the anhydride will be benzene carboxylic anhydride. And this is another example where that acid has a common name. It's usually called benzoic acid, and so you could also call this benzoic anhydride. Now for the final example, now we have two different acids. One of them has a methyl group coming off. They're both going to be 1, 2, 3 propanoic acids, but this one has a methyl, which is going to make it come first alphabetically. And so now we have to name both of them. So the first one will be 2-methyl propanoic. The second one will just be propanoic. And finally, anhydride. So 3 words because there are 2 different acids and then anhydride after that. So next, let's talk about amides. Amides have amide as the suffix. When they're attached directly to a ring, the suffix is carboamide, sort of the same pattern we've seen before. The carbon, again, is part of the root, meaning that the C double bond O will be the first carbon in the chain, always. And then anything on the nitrogen of the amide will be a substituent. And if amide itself is a substituent, the prefix is carbomoyl. So let's just look at a couple of examples. Again, because it's at the beginning of the chain, you don't have to indicate the position. So this is a 1, 2, 3, 4, 5 carbon chain. So that is pentane amide, like so. Now for the second one, the chain starts here because it's attached to a ring, and then there are 2 methyl substituents. So for the methyl substituents, it will be N dimethyl, and then the root will be cyclohexane, carboamide, because that's how you name it when it's attached to a ring. And so for the final example, the chain is 1, 2, 3, 4 carbons long. The amides are on both ends, and so we call this butane diamide. And again, no position needed when it's on the end, so that's it. Now let's look at nitriles. Nitriles are pretty simple. It's just a CN group, and nitrile is the suffix. When it's attached to a ring, we call it a carbonitrile. And if it's just a substituent, it's a cyano group. So we're going to look at this one example. Here, the ketone is not the highest priority group. The cyanate is. So it's going to start 1, 2, 3, 4, like that. And so 4-oxo is now a prefix that takes care of the ketone. The root is cyclohexane, and the suffix is carbonitrile, which is on carbon 1, so I don't have to include that. And let's look at a couple more examples that have multiple groups on them. So for the first one, the carboxylic acid is the root, and so the numbering will go this way. I can go either way. And so in this case, we have 3, 5 dioxo, and then the root is cyclohexane. And then the suffix is carboxylic acid, like so. And now for the second molecule, again, the functional group is attached to a ring, so the numbering will go like this, and the substituent is right here. So I have N-methyl. And then the root is cyclohexene. With the double bond on 3. And for an amide, we say carboamide. And again, we know that's on carbon 1. So that's it.